What we're doing here is assessing oilseed rape from our companion plant trial for cabbage stem flea beetle larvae. So the typical historical way we used to do that is we'd take the plants, we'd get into the lab, we'd dissect them under a microscope, which is very labour intensive, takes a lot of time, takes quite a bit of skill, and the number of counts that you get on flea beetle larvae can be variable depending on the skill level of the person assessing. But the reason we do it this way is it then means if you set them up, if I set them up, Harry sets them up, if Bree sets them up, anyone who sets them up, the amount of larvae that are going to come out will be the same. It's not there isn't a observer or user bias within this. This is Sam Bircham, one of our field team, who's been working on the Ekhaga companion plant trials. He's the one who's leading it for us from our ADAS site here at Boxworth. We also have members of our field team at our Gleethorpe site. This is Ryan Mitchell and Lauren Gammons who are doing our field work from up at the Gleethorpe site. So excellent hats off to the ADAS field team. They do a great job for us. What we've got here is effectively buckets with a bit of water in them, a bit of washing up liquid to break surface tension, and then something to help preserve. So in the case of this, we use Camden tablets. So any home brewers out there, it's the same stuff you use to keep your home brew clean. And what we do is we then set mesh, and you'll be basically setting the mesh on top of these. We put the oilseed rape plants on it. As the plant dries out, the cabbage stem flea beetle larvae exit the plant because they don't want to die inside the dying plant. But because we've set them up over these tubs, they then come out of the plant, they fall into the water, they fall, then drown in that water, and we come back and we can count those larvae. And that's what's being set up here. So that's what we're basically doing. We are collecting the plants, extracting the cabbage stem flea beetles in a consistent way across the field trials. So all of our 3 field trials in the UK are all getting set up in this same polytunnel here today. And we will then come back and keep periodically checking, count the flea beetle larvae that are in there, and it will give us our assessment of what's happening for larval pressure dependent on the level of companion plants we have out in the field. Right, so we're setting up this passive assessment. So we've got our buckets with the water and a bit of detergent in. The next bit is then to affix mesh or chicken wire onto the top of the container. So in this case, we use some rigid bird netting because we've found for our field work and our team, it's less sharp but still robust enough to hold the plants up. So we effectively attach these to the plastic containers, and it does relatively work as a support to put the oilseed rape plants on. So as they dry out, the flea beetle larvae will then fall through the mesh into the water as we want. So we take our sample from the field. Thankfully, we have a nice written label so that we can get our sample number. First thing that we typically do with these is we put one underneath so that it can't get lost. And when we come back to assess, we can refer back to exactly where this plant sample came from. We then have a second label, which we have to put on the top. So again, we can know exactly where this has come from when we come back and assess it in a few days or weeks' time. We then take our oilseed rape plant sample and we then distribute it across the top of the mesh. With effectively, the process is to allow these plants to dry out. As they dry, the cabbage stem flea beetle larvae will want to exit the plant, and as they exit, they will fall into the bucket underneath, and we can come back and collect them. So we will come and check these at several points, because as the plant starts to dry out, they will shrink in size, so we'll need to make sure the larvae go within inside. And the best way of doing this for a truly, really accurate mod would be a single pot per single plant, because of space limitations, we do multiple plants over a single pot. But as long as we know how many plants go on top, we can then calculate how many larvae there are on an average per plant, and then we can use that to understand larval pressure on the basis of our treatments within the field, and understand our companion plants at different seed rates affecting the number of cabbage stem flea beetle larvae we actually get in our crop plant. As it's cold in the year, these will stay in here. They won't dry quite as efficiently as they would if we're in spring or in a nice heated space. So we'll just need to come in and check on a regular basis how the drying is going, redistribute the plants to allow even drying. As long as we do that consistently across all the plots within this trial, we'll have a comparable data set. So we'll just keep keeping an eye. And I will be coming back as well anyway, because I want to collect some larvae from some of these so that I can store them for potential genetic screening for resistance traits that we may work on a collaborative project with Rothamsted in the future, but I just want to gain some samples.
Yeah.
So we'll come in and keep an eye on it as they slowly dry. Once we hit a kind of good consistent dry point, then we'll collect our flea beetle numbers and assess those.